Natural log. Finally, we come to the definition of natural log. The functional natural logarithm is the function log base e. Remember that Euler number e. Log base e of x, that's called the natural logarithm. It has domain 0 to infinity and range negative infinity to infinity. Log base 2 is a very special function, so it has its own notation, ln. So ln for natural logarithm. The function is denoted by natural log ln of x. What does that mean? Natural log of x is y if and only if e to the power y is x. Okay. Moreover, because natural log is inverse of the exponential, natural log of e to the x is x. This happens for every x in the number line, and e to the natural log of x is x. This happens for every positive x. All right. In particular, natural log of e is 1. Why? Because natural log of e is natural log of e to the power 1. So they are inverse functions. So 1 jumps out, that's all. Solve for x. Natural log of x is 9. How do we address this equation? Well, natural log of x is 9. Take exponents. You see, the base is e. So you would raise both sides to power of e. E to the natural log of x is x. They are inverse functions. All right. And e to the 9 is e to the 9. You have solved for x. You cannot do any better. Likewise, e to the power 3x is 5. Solve for x. Right? So how do I get rid of that e? Well, that's the base. So take natural log. That is log base e of both sides. Whatever do you do to one side, you must do to the other side. Natural log of e to the power x, power 3x is 3x, because natural log e and e to the power, these are inverse functions. So you get the exponent down. That's natural log of 5. Now you can solve for x. X is 1/3 natural log 5. Okay, dividing both sides by 3. Now you may leave it like this, or you may use one of the results in our previous theorem. This is nothing but the exponent can go in, natural log of 5 to the power 1/3. But what is 5 to the power 1/3? It's cube root of 5. So the answer is x equals natural log cube root of 5. Here is a little more complicated function. Equation. Natural log of 4x minus 5 is 2. Well, what is the inverse of natural log? Exponential base e. So taking e to the power of both sides, e to the power natural log 4x minus 5 is e to the power 2. These are inverse functions, so essentially they cancel. You're left with 4x minus 5 is e squared, which is a real number, so let it be. Now you can solve for x. Move 5 over and divide by 4. Lastly, here is e to the 4x plus 7 is 2. E to the 4x plus 7 is 2. Take natural log of both sides. Why did I do that? To find the inverse of e, exponential function, or to cancel e, natural log. Natural log of e to the 4x plus 7, they undo each other and you're left with 4x minus 7. And right hand side is natural log of 2, which is a real number, so let it be. Now you can solve for x. Move the 7 over, divide by 4. All right. So we'll come to the next theorem in our next, let's finish it. Theorem 2, change of base formula. You see, if you look at your calculator, you will find natural log and you will find log base 10. But what if I want log base 3 or 5 or I don't know, log base half? Here is your theorem. Log base b of x is natural log of x over natural log of the base. How do we go about this? Well, suppose this is y. Let y be log base b of x. that is b to the power y is x. That's what this means, right? B to the power y is x. Now I have a calculator, so I'm going to apply natural log to both sides. Natural log of b to the power y is natural log of x. Now using the properties of logarithmic function, you see the power has to jump out. Y times natural log b equals natural log x. Well, at this point, I can divide both sides by natural log b. Y equals natural log x over natural log b. What was y? That was log to the base b of x. That's natural log x over natural log b. We have proved this theorem. Okay. So next videos will cover problems from our web work. So I'll continue in our next video. Until then, bye.